Hi there. Recall that in a previous video on conic sections, when we cut these cones parallel to the generator, we form this curve out here. This is what we call the parabola. In this video, we'll be learning what it is, its parts, and lastly, the equation of a parabola. So starting with its definition. So we define parabola as the set of points equidistant from a fixed point and a line. Its graph is given by this. But take note that we can also have a parabola of this form, and of this, the other way around, and of this form. So it depends on its orientation, but we'll be dealing with that more later on. So to understand this definition much better, let's first define some terms. So first, this fixed point out here refers to the focus, and its point in the graph is placed here. On the other hand, this line out here refers to the directrix, or the line out here. So when we say this is the set of points equidistant from the focus and the line, this means that if we take an arbitrary point xy in this parabola and take its distance from the fixed point focus, as well as take its distance from the line, so when we take this distance, it's just perpendicular to this. When we take these two distances are actually equal. Although it's not accurate, the graph is not accurate when you try to put it on a graphing calculator and try to measure it. These two distances are indeed equal. And you can do the same for other points out here. Take this, take this and that. These two would be equidistant. So now that we know this, let's define more terms in the parabola. Or in other words, we'll define some of its important parts, starting with the vertex. So we define vertex as a special point in the parabola. So it is a special point since usually the vertex, let's put the vertex out here, it's located out here, it is the determiner of the maximum point or either the minimum point of a parabola. So it's a nice point to study. Aside from this, we put midpoint out here since if we take another point out here, so a point in the directrix that is in line with the focus, the vertex represents the midpoint of the focus and a point on the directrix. So that's why we refer to it as a midpoint. Aside from the vertex, we have the major axis. So this is defined as the line that passes through the vertex and the focus. So the vertex is out here and the focus. A line that passes these two is given by this. So this out here is our major axis. And lastly, we have the latus rectum. The latus rectum is a line segment that is perpendicular to the major axis, this violet line out here, that contains the focus. So it is a line segment wherein the endpoint is at the parabola. So it is given by this. So this one out here is the latus rectum. So these are the important parts of a parabola that you need to remember. Now, given this, we now know the definition of a parabola and its parts. The last thing that we do is find its equation, or the equation of a parabola. So we'll try to derive this given this graph out here as well as its definition. So let's first resize this one and move it out here and rotate it. take note that we rotated it since the classical example of a parabola is a parabola opening upwards, or this type of a parabola. So we'll try to examine this one. But first, let's remove some parts of this parabola that we don't need, starting with the major axis and the latus rectum. Okay, good. Next step, let's try to put this figure out here in a graph. So we try to place it in the number line, or the Cartesian plane rather, wherein the vertex is at the point 0, 0. So take note that this isn't always the case, but for this derivation, we do this one to make things easier. Aside from this, since we know that by the definition of a parabola, the distance of any point in the parabola is equidistant to the focus and the directrix, then we know that this distances out here, let's denote it by p. So essentially, these two distances are equal, which we denote by p. This actually refers to the focal distance of a parabola. So given that, so let's try to put a point out here first, since we'll be needing that later. We know that this focus out here, the pink point, is given by the point 0, p, and the point green, or the green point out here, is represented by the point 0, negative p. So we'll be needing these results later on. Aside from this, let's put another point out here in the directrix. And let's denote this orange point out here to be the point xy, since it is just an arbitrary point in the parabola. Given xy out here and the point 0, negative p, we know that this point must be the point x, negative p. And so now that we have this, how do we derive the equation of a parabola? Well, take note that the key in the parabola equation of a parabola is that we know that given an arbitrary point, in this case xy, its distance from the focus and the directrix is equidistant, or it's the same distance. So if you denote this as d1 and d2, the key to obtain the equation of the parabola is to equate these two. So we'll do just that. But first, take note again, p out here refers to the focal distance, and we need the distance formula, so let's take note of that. So the distance formula, given 2 points, is given by d equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So given this, we are now ready to derive the equation, starting with the first distance. So we use these 2 points, wherein let's denote this as x1 and y1. This one is x2 and y2. Or actually, let's do the reverse. Either way, it's the same. Let's do this as the x1 and y1, and this one is the x2 and y2. So given that, we'll have the first distance as this one. So we have x minus 0 squared plus y minus p squared. So this simplifies to x squared plus y minus p squared. Square root in outside. Now let's obtain the second distance. So we denote this to be x sub 2 and y sub 2 again, and this one as the x sub 1 and y sub 1. So we'll have this one out here, x minus x squared plus y minus negative p squared. This one out here becomes 0, and this one out here becomes y plus p squared. So we use these two distances and equate them. So we'll have the square root of x squared plus y minus p squared equals the square root of y plus p squared. So now that we have these results, so let's clear out some space first and move this up. By further steps, we can now obtain the equation of a parabola. We start by squaring both sides to obtain x squared plus y minus p squared equals y plus p squared. Next, take note that we can expand these two out here to obtain x squared plus y squared minus 2py plus p squared equals y squared plus 2py plus p squared. So essentially what we did is to apply the square of a binomial. In here, observe that we have y squared and y squared on the both sides of the equation, as well as p squared. So we can subtract y squared and subtract p squareds both sides to cancel these two, and we'll be left with x squared minus 2py equals 2py. Move negative 2py rather, to the right, and we get x squared equals 4py. This out here is already the simplified form of the equation of a parabola, to be specific, at vertex 0, 0. So this is something that you need to take note. So essentially, this is the equation of a parabola. But unfortunately, the vertex isn't always at the point 0, 0. So actually, this isn't really the general form of the equation of a parabola. We just derived this version, the point or the vertex at 0, 0, since it is clearer and easier that way. But with similar steps, we can derive that in general, the equation x minus h squared equals 4p times y minus k squared is the general equation of a parabola. So take note here that the h and k, the hk refers to the vertex, the point of the vertex, and p out here again refers to the focal distance. So again, this one out here is the equation of a parabola in general. And actually, we call this one as the vertex form, rather. The vertex form of the parabola. So this is something that you need to remember and recall. But take note that this equation only applies for parabolas of this form, or parabolas that is oriented vertically. But what if we have these types of parabola, or parabolas that are oriented horizontally? Well, the equation would be similar to this, but with some minor changes. And that is something that we'll be dealing with in the next video. More particularly, what we'll be focusing on the next video is dealing with the vertex form and parabola in general, with the vertical orientation and the horizontal orientation. So yeah, I hope you enjoyed and learned a lot from this one. Feel free to comment down below if you have any comments, suggestions, and recommendations regarding this video and the channel in general. So yeah, that is it, and that is all for this video.